Hi, Pre-Calculus 11 students. This is an answer key for the Trig Lesson 5 homework. And remember, that was from the Pre Calc 11 textbook. And it is pages 96 and 97, numbers 1 to 11. Okay, so we'll start with number 1 here, and it says sketch an angle in standard position so that the terminal arm passes through each point. And the first point that they give us is 2, 6. Okay, and so the angle would look like this. There's 6, there's 2, there's 2, 6. And the angle always goes from the positive x-axis, which is called the initial arm, to the terminal arm like that. So there's angle theta. Okay, so there's 1A. Letter B, the point is -4, 2. One, 2, 3, -4, like that. And 2. Could do that, and the angle looks like so. Okay, letter C, excuse me, the point is -5, -2, One, 2, 3, 4, -5, and -2 is down like this. Okay, so the point is about there, and then the angle is like so. And finally, letter D, we have the point -1, 0. -1, 0 is right there. That's the terminal arm. The initial arm would be out like this, and the angle is like that, 180 degrees. Okay, let's check out number 2 here. It says determine the exact values of the sine, cosine, and tangent ratios for each angle. Okay, when we talk about exact values, that means the special triangles. The 45, 45, 90 triangle, which goes 1, 1, √2. And the 1, 2, √3 triangle, which is 30 degrees, 60 degrees, and 90 degrees. Okay. And so you can see that the angles that these triangles are relevant for are 30 degrees, 45 degrees, and 60 degrees. Okay, so we can get exact values for sine, cosine, and tangent for those angles, but also angles who have these as reference angles. Okay, so in 2A, determine the exact values of the sine, cosine, and tangent ratios for each angle. So basically it's showing you a 60-degree angle. So we would do sine 60, look in the 30, 60, 90 triangle and do opposite over hypotenuse, root 3 over 2. Cos 60, I would do adjacent over hypotenuse, which is 1 over 2. And tan 60 is opposite over adjacent, root 3 over 1, so just root 3. I guess I could do root 3 over 1, which is root 3. Okay, and this is in quadrant 1. All trig ratios are positive in here, so all of our answers should be positive. Remember the cast rule, right? Like this. Okay, so that's 2A. All right, let's do letter B. They give us an angle of 225 degrees. And if we were to get just this little reference angle part, so remember half a circle is 180, so you'd have to go 225 minus 180, so that's 45 degrees. And they want the exact values of sine, cosine, and tangent for this 225 degrees. So sine of 225 degrees, it's going to be equal to sine of the reference angle, sine of 45 degrees, with the appropriate plus or minus sign in front. So from the cast rule, tan is the only one that is positive in that quadrant. So sine of 225 will be negative sine 45. And we could also do cos 225. It's going to be equal to cos of 45 degrees. Tan is the only one positive in that quadrant, so that's going to be negative. And tan 225 is equal to tan 45 degrees, and in quadrant 3, where the 225 degree angle is, tan is positive, so that one will stay as positive. And I guess we have to look at the 45, 45, 90 triangle, which goes 1, 1, root 2. And sine 45 is opposite over hypotenuse, so 1 over root 2 with a negative sign in front. Cos 45 is adjacent over hypotenuse, which is 1 over root 2. And we have a negative sign in front of that one as well. And tan 45 is 1 over 1, which is just equal to 1. Okay, and so that's what we get for 2B. All right, let's do part C. We have an angle of 150 degrees. Which means the reference angle is 30 degrees. So if we wanted to figure out sine of 150 degrees, cos of 150 degrees, and tan of 150 degrees, which is what the question wants, this would equal sine of 30 degrees. And notice how sine is positive in quadrant 2, so sine of 150 will be positive, same as sine 30. In quadrant 2, yes, sine is the only one positive, so cos of 150 will be negative cos 30. And tan of 150 degrees would be negative tan 30. And so then we need the 30, 60, 90 triangle, which goes 1, 2, root 3. Sine of 30 degrees is opposite over hypotenuse, 1 over 2. Cos of 30 is adjacent over hypotenuse, root 3 over 2 with that appropriate sign in front, negative. And tan of 30 degrees is opposite over adjacent, 1 over root 3, and it's negative of that. All right, let's get on to 2D here. Throwing a little curveball at us. Okay, they're doing a 90-degree angle. Okay. And I think what we can assume here is that we've got a circle of radius 1, and so this point here would be 1, 0, and this point here would be 0, 1. And remember, sine theta is y over r, and if r is 1, then that would just mean that sine theta is the y-coordinate, and cos theta is x over r, and since r is 1, that's x, and tan theta is y over x. Okay, so sine theta is the y-coordinate, so sine 90 is the y-coordinate. Cos of 90 is the x-coordinate, and tan 90 is y over x. 1 over 0, which is undefined. Okay, so just verifying with the answer key. Everything looks good with 2C, and then D, they've got 1 and 0, and tan 90 is undefined. Great, let's get on to number 3. And it says the coordinates of a point P are shown on the terminal arm of each angle. The coordinates of a point P on the terminal arm of each angle are shown. Write the exact trig ratios, sine, cos, and tan for each. Oh, okay. Okay, so the first one they show us is something like this. And they give us this point 3, 4. Okay, and the definitions of sine, cos, and tan are the following. Sine is y over r. Cos of theta is x over r. And tan theta is y over x. Okay, and so of course, as the coordinates go, that is x and that is y, so we can get tan theta, it's y over x, so simply 4 over 3. We need to figure out r, the radius, and remember we had that little property x squared plus y squared equals r squared. Okay, because you could set up a 90-degree triangle. This is your x distance, this is your y, and then this was r, which was the radius of the circle, and that's sort of how this works. Okay, Okay, so x squared plus y squared equals r squared, Pythagoras, so you would go 3 squared plus 4 squared equals r squared. And this is 9 plus 16 equals r squared, so r squared equals 25. So r is plus or minus the square root of 25. R is a radius, so r is 5. Okay, so sine is y over r, so 4 over 5. And cos is x over r, so 3 over 5. And so those are the exact trig ratios for sine, cos, and tan. Okay, let's try letter B. We have the point -12, -5, so they've got it out like this. And the angle is here, theta. Sine theta is y over r, cos theta is x over r, and tan theta is y over x. And to get r, which is here, we would go r squared equals x squared plus y squared. The x is -12, so it's -12 squared plus -5 squared. And we are going to get 144 plus 25. So r squared equals 169. So r is equal to plus or minus the square root of 169. R is a radius. So r is equal to 13. Okay, so this is x and this is y, so sine of theta is going to be -5 over 13, cos of theta is -12 over 13, and y over x, -5 over -12, which is 5 over 12. Okay, and that's, you can kind of see the cast rule happening there. That's why tan is the only one that's positive in quadrant 3. Okay, so what was this? This was 3b. Excellent, let's get on to 3c. We have this, there's angle theta. And we've got the point 8 and -15. This is x and y. Sine theta is y over r, cos theta is x over r. And tan theta is y over x. We can actually do that one right away. That one's -15 over 8. We have to figure out r. R squared is equal to x squared plus y squared. So 8 squared plus -15 squared. And let's quickly figure that out. Eight squared plus -15 squared would be the same as 15 squared, so I'm just going to go 15 squared. We're going to get 289 for this. So r is equal to plus or minus the square root of 289, which I think is 17. If I do the square root of that, yes, plus or minus 17. R is a radius, so 17. Y over r, we would get -15 over 17. And x over r is 8. over 17. And that is 3C. Perfect. Let's get on to 3D. Okay, this time the angle is like this. Point is 1, -1. Okay, and this is x, and this is y. So r squared is equal to x squared plus y squared. R squared is equal to 1 squared plus -1 squared. Okay, so that's going to be 1 plus 1. R squared equals 2, so r is plus or minus √2. It's a radius, so √2. The y is -1. The r is √2. And you may see in the answer key that they will write another form of this answer by rationalizing the denominator. And so what they do is they just multiply top and bottom by √2. It's called rationalizing the denominator, just in case you're wondering where they get this other answer from. -1 times √2 is -√2. And of course, √2 times √2 is just 2. And it gives you like a nice non-square root number on the bottom. So that's the rationalized answer. I would probably just leave this answer. I like that answer. Cos is x over r. X is 1. R is √2, so just 1 over √2. Let's leave that. And y over x, -1 over 1, which is -1. Okay, in the answer key, it's got -1 over √2 for sine, or that other one. It's got cos is 1 over √2, or a rationalized answer, and tan theta is -1. Perfect. All right, on to number 4, everybody. Okay, for each description, in which quadrant does the terminal arm of the angle lie? And it's saying that cos theta, so this all comes down to the cast rule. Cos theta is less than 0, and sine theta is greater than 0. Okay, so all you have to do with this, guys, is write down the cast rule and say, hey, if sine theta has to be greater than 0, sine theta is positive. Where is sine theta positive? Well, in quadrant 1 and quadrant 2. And where is cos negative? Cos is negative. Well, first of all, cos is positive in 1 and 4, so cos is negative here and here, and you choose the one where you have the overlap, where sine is positive and cos is negative. So our angle would have to be in quadrant 2. Right? See how this is quadrant 2 here. 3 and 4. Okay, so 4A, excuse me, is quadrant 2. Letter B, where is cos positive, greater than 0? And tan of the angle theta is also positive. Cast rule. All trig ratios are positive here, so cos is positive here, and cos is positive here. Where is tan positive? Tan is positive here and here. So that's where they are overlapping in quadrant 1. Letter C, sine theta is less than 0, so negative, and cos theta is less than 0, so negative. So a quadrant where both sine and cos are negative. Cast. Sine is negative here and here, and cos is negative here and here. So it's that one, which is quadrant 1, 2, 3, and 4. Quadrant 3 is our answer. Okay, and finally, letter D. We want tan of theta to be less than 0 and cos of theta to be greater than 0. Cast. So where is cos positive? Here and here. And where is tan negative? Well, we know that tan is positive in 1 and 3, so tan would be negative here and here. And so that's where we get the overlap. Okay, so tan is negative and cos is positive in quad 4. Okay, so that's how you do number 4. Now, number 5 says determine the exact values of sine theta, cos theta, and tan theta if the terminal arm of an angle in standard position passes through the given point. So this is very similar to number 3. And in A, the point is -5, 12. So -5, 12 would be like in here somewhere, right? And the angle would be like this. And we have to get r. R squared is equal to x squared plus y squared. Okay, -5 squared plus 12 squared is 169. So r is equal to plus or minus the square root of that. R is equal to plus or minus 13. And since r is a radius, we take it to be the positive. So sine of theta, by definition, is y over r. Cos theta is x over r. And tan theta is y over x. So our y-coordinate is 12 and our r is 13. X over r is -5 over 13, and y over x is 12 over -5, and we usually write the negative on the top or in the middle of the fraction, and that is 5a. Okay, let's check out B. The point is 5, -3. Okay, so this is the point 5, -3, and the angle is like this. Sine theta is y over r, cos theta is x over r, and tan theta is y over x. So we have to figure out r. R squared is equal to x squared plus y squared. 5 squared plus negative 3 squared. 5 squared plus negative 3 squared is 34. So r is equal to plus or minus the square root of 34, and since r is a radius, we'll just take the positive root 34, and that doesn't break down very nicely, so we'll just leave it as root 34. So y over r for sine theta is negative 3 over root 34. X over r is 5 over root 34, and y over x is negative 3 over 5. Excellent. Let's get on to 5C. The point is 6, 3. Let's say it's here, 6, 3, and there's the angle. R squared is x squared plus y squared. 6 squared plus 3 squared. So what is that? 36 plus 9. So r squared is equal to 45. So r is plus or minus root 45. R is root 45. Sine theta is y over r, so 3 over root 45. Cos theta is x over r, which is 6 over root 45. And tan theta is y over x, which is 3 over 6, which I guess we could break down to 1/2. All right, and that's good for 5C. And letter D, we are at the point negative 24 and negative 10. Let's just say it's like this. Negative 24 in the x direction and negative 10 down like that. R squared is equal to negative 24 squared plus negative 10 squared, which would be the same as 24 squared plus 10 squared. So let's just do that, 676. So r is equal to, what is the square root of 676? Oh, it's 26. So r is plus or minus 26, but since it's a radius, r is 26. Okay, so sine theta is y over r. The y coordinate is negative 10. The r is 26. I guess we could put that in lowest terms. Negative 5 over 13. Cos theta is x over r. The x is negative 24. The r is 26. Divide both top and bottom by 2. And tan theta is y over x, which is negative 10 over negative 24, which is 5 over 12. Okay, perfect. So there's number 5. All right, let's get on to number 6. It says, without using a calculator, state whether each ratio is positive or negative. So this is using the cast rule. 155 degrees would be like that. And so sine is positive in that quadrant, and it's asking about sine of 155 degrees. Since, see how that S sign is positive in that quadrant, we would get a positive result for sine 155. Okay, we can check if you want. See how that's a positive result. Part B, cos of 320 degrees. So we have to locate 320 degrees. So we usually start positive x-axis. There's 90 degrees, 180, 270, all the way around is 360. So 320 will be somewhere in here. Cast rule. Cos is positive in that quadrant, so cos of 320 degrees will be positive. And they told us not to do this, but even if you want to just check it out, hey, cos of 320 degrees is that positive ratio. Letter C here, tan of 120. There's 90 degrees. It's 180 to the next line x-axis there. So 120 will be somewhere in here. Quadrant 1, quadrant 2. Actually, we don't need quadrants, do we? We need the cast rule. Cos is positive. All trig ratios are positive. Sine is positive, and tan is positive. So, tan of 120 degrees, since sine is the only one that's positive in there, this will be negative. Tan 120 degrees is negative. And we can see that right there. And part D, cos of 220 degrees. We've got 90, 180. Next line would be 270, so 220 would be somewhere in here. Cast. Tan is the only one that is positive there, so cos of 220 degrees will be negative. Okay. All right. Number 7. An angle is in standard position such that sine theta equals 5 over 13. Sketch a diagram to show two possible positions of the angle. Okay, so here's what you do. Sine theta is equal to 5 over 13. And we know that by definition, sine is y over r. Okay, so we need the y-coordinate to be positive 5, and we need the radius to be 13. Okay, so if the y-coordinate is positive 5, and the radius is 13, it could be like an angle here. Right, we don't know what x is. Or if you're at a y height of 5 and a radius of 13, the angle could be like this. Okay, so sketch a diagram to show two possible positions of the angle, so it could be either of those. Okay, and I just want to make sure things are good with my answers up above. We got positive, positive, negative, negative. That looks good. Answer key. Okay. Okay, we could figure out the x-coordinate doing x squared plus y squared equals r squared. X squared plus the y is 5, right? So 5 squared equals, and we know that the radius was 13. So x squared plus 25 equals 169, and subtract 25 from both sides, and we end up getting x squared equals 144, and so x equals plus or minus the square root of 144, and so x equals plus or minus 12. And in the first quadrant, the x-coordinate is positive 12, but over here in the second quadrant, the x-coordinate would be negative 12. So our points would be like that. Okay, so those are the two possible angles. Part B says determine the possible value of theta to the nearest degree if theta is between 0 and 360. So if sine theta is equal to 5 over 13, then theta is sine inverse of 5 over 13. And when they're both positive, or when your ratio is positive, this is going to give us the reference angle, or essentially the angle in the first quadrant, which is 23 degrees. I did mine in degrees. See how my calculator is in degrees? So 23 degrees, that's what this one is equal to. Okay, but that's also the reference angle. And so then in quadrant 2, the reference angle is here, 23. So theta equals 23 degrees in quad 1, and theta equals 180 degrees minus 23 in quadrant 2. So 157 degrees in the quadrant 2 possibility. Awesome. Let's get on to number 8. An angle in standard position has its terminal arm in the stated quadrant. Determine the exact values for the other two primary trig ratios for each. Okay. 8a. It says we're in quad 2. So the angle is like this. Cos theta is equal to negative 2 over 3, and that's equal to x over r. R is always positive because it's the radius, so the r is 3. That means the x has to be negative 2. The x-coordinate is negative 2, and then we can figure out y using that formula, right? X squared plus y squared equals r squared. So negative 2 squared plus y squared equals 3 squared. So 4 plus y squared equals 9. Subtract 4 from both sides and you get y squared equals 5. So y is equal to plus or minus the square root of 5. And looking at the position of our point, that y coordinate is up, right? So it's positive. So y is the positive root 5. So we'd have root 5 in there. And then what does it want? Determine the exact values for the other two primary trig ratios. So they want sine theta, which by definition is y over r, so root 5 over 3, and tan theta, which is y over x, root 5 over negative 2, which we would write with the negative above, right? Like so. Okay, 8b, we have sine theta equals 3 over 5. And we're in quadrant 1. So the angle is like this. And sine is y over r, so the radius is 5, and the y coordinate is positive 3. And so to get x, we would go x squared plus y squared equals r squared. So x squared plus 3 squared equals 5 squared. So x squared plus 9 equals 25. Subtract 9 from both sides. X squared equals 16. So x is plus or minus the square root of 16. So x is plus or minus 4. And looking at where this point is, we have to head out to the right and then up. So the x coordinate is positive 4. And then we can say cos theta is x over r, which is 4 over 5. And tan theta is y over x, which is 3 over 4. And we're done. Okay, letter C, tan of theta is negative 4 over 5, and we're in quadrant 4. Okay, so the point is here, and remember that the definition of tan theta is y over x. You just got to be a little bit careful about which one is positive and which one is negative. In this case, we're kind of lucky because the y coordinate is down, so the y is negative 4, and the x is positive 5 because we'd have to head out to the right here 5 units. Okay, so sometimes you got to be a little bit careful with where those positives and negative signs land. Okay, but this one works out for us. And r is the radius. R squared is equal to x squared plus y squared. 5 squared plus negative 4 squared. So r squared is 25 plus 16. R equals 41. Sorry, r squared equals 41, so r is plus or minus root 41. and r is equal to the square root of 41 because it is always positive. So they want the other two ratios. Sine theta is y over r. The y is -4 and the r is root 41. And cos theta is x over r. X is 5 over root 41. Okay, what was that? 8c? All right, we're getting there, guys. 8d, sine theta is equal to -1 over 3, and we are in quadrant 3. Okay, so the angle is here, and sine is y over r. The radius is always positive, so that's going to be 3. The y-coordinate is -1. Awesome. X squared plus y squared equals r squared. So x squared plus -1 squared equals 3 squared. Subtract 1 from both sides and we get x squared equals 8. So x equals plus or minus the square root of 8. And is it positive or negative? Well, you see how we'd have to move to the left. So that x coordinate is negative root 8. Okay, they've already figured out sine theta for us. So we just want cos theta, which is x over r, negative root 8 over 3, and tan theta, which is y over x, and that's going to be -1 over negative root 8. -1 over negative root 8, which is 1 over root 8. Okay, and I think I'm just noticing in the answer key that they actually simplified root 8 into root 4 times root 2, which is where they're getting -2 root 2 over 3 from. Sorry, -2 root 2 over 3. And then this one here, what are they doing with that? They're multiplying top and bottom by root 8, first of all, to rationalize the denominator. So we end up getting root 8 over 8, but then we can simplify root 8 into root 4 times root 2, which is 2 root 2 over 8. Sorry, not root 8 on the bottom. Okay, and of course 2 over 8 can be simplified to 1 over 4, so we've got that root 2 on top, so root 2 over 4, and that's what they wrote in the answer key for tan theta. Okay, let's get on to letter E. We have tan theta equals 1, and we're in quadrant 3, it's saying. And tan is y over x. So to get 1, I guess we'd have to just be 1 over 1. Like so. And r squared is equal to x squared plus y squared. So r squared is equal to 1 squared plus 1 squared, which is 2. So r is plus or minus root 2, but r is a radius, so we take it to be positive root 2. And the definition of sine theta is y over r, so 1 over root 2. Oh, and I actually made a big mistake here with the point, right? This is negative 1 and negative 1. So it's negative 1 over root 2. And cos theta cos theta is x over r, and the x-coordinate is also negative 1. And that's what we would get for 8e. Okay, number 9, solve each equation for theta between 0 and 360 using a diagram involving a special right triangle. So in A, they're saying cos of a certain angle is 1 over 2. Where is cos positive? In quadrant 1 or quadrant 4? 1 or 4. So then we have to figure out the reference angle, which is cos inverse of 1/2. If you go shift cos of 1/2, we get 60 degrees. So 60 degrees here, 60 degrees here. And so then our angles are 60 degrees in the first quadrant, and in the fourth quadrant, 300 degrees. And those two angles would give you a cos of 1/2. Okay, in letter B, we have cos theta equals negative 1 over root 2. And where is cos negative? Cos is positive in 1 and 4, so it's negative in quad 2 or quad 3. Quad 2 would be an angle like that, and quad 3 would be an angle like this. So we need to get the reference angle, and you do that by going cos inverse of just the positive ratio there, because that pushes everything into the first quadrant, which gives you the reference angle. So we would go shift cos of 1 over root 2, and we get 45 degrees. So the reference angle is 45 degrees. So that's 45 and that's 45. So the rotation angles are From here, we'd have to go 180 minus 45, so 135 degrees for that angle. And for this whole big angle in quadrant 3, we have to go 180 plus 45, which is 225 degrees. Okay, I'm going to do a little pause here. Okay, let's do 9C, which looks like this. They want us to solve this equation. Tan theta is equal to negative 1 over root 3. And so from the cast rule, tan is positive in quadrant 1 and 3, so it will be negative in quadrant 2 or 4. So our angle will be either not there in quadrant 2. Okay, so the angle will either be like this, or in quadrant 4. Okay, and in order to find those two angles, we need to get the reference angle. So the reference angle is here and here, and the reference angle is equal to, you would do tan inverse of the positive of that ratio, which is equal to, if we go shift tan 1 over root 3, we get 30 degrees. Okay, so this little angle here is 30 degrees, and this is 30 degrees. So our rotation angles, theta, that work are going to be, this whole angle right here is going to be 180 minus 30, so 150 degrees. And then in here, all the way around the circle is 360. 360 minus 30 is 330 degrees. And remember, we wanted to solve this for theta being greater than or equal to 0 degrees, but less than 360. So in that range, and those are the two angles that work. Okay, let's do letter D. It is sine theta equals negative root 3 over 2. Where is sine negative? It is positive in quadrants 1 and 2 according to the cast rule, right? Sine is positive here and here. So it would be negative in quads 3 or 4. Okay, so this angle or this angle. All right, the reference angle is going to be sine inverse of root 3 over 2. Shift sine, root 3 over 2. Okay, and we get a reference angle of 60 degrees. Okay, that means that this little angle is 60, and this little angle here is 60. So the rotation angles are theta equals, we're going to have 180 plus 60 in quadrant 3, so 240 degrees, and over in quadrant 4 it's going to be 360 minus 60, which is 300 degrees. Okay, so if we check that, oh, actually it's complicated to do that. Well, not too bad. Check this out. Sine 240 is that, and sine 300 should be the same thing. Is that equal to negative square root divided by 2? Yes, it is. Okay, so there we go. Okay, letter E. Tan theta equals the square root of 3. Where is tan positive? Either in quadrant 1 or quadrant 3. The reference angle is equal to tan inverse of root 3. So we go shift tan square root 3, which is 60 degrees. Okay, so this is 60 degrees here, and this is 60 degrees right here. So theta in the first quadrant is equal to the reference angle, 60 degrees, and in the third quadrant, it would be 180 plus 60, so 240 degrees. Okay, just checking some answers with the answer key. And finally, letter F, we've got tan theta equals negative 1. Where is tan negative? In quadrant 2 or 4. So the angle would be like this or like this. The reference angle is going to be tan inverse of negative 1. So if we do that, shift tan of negative 1. Sorry, not of negative 1. You make the ratio positive to get the reference angle. Shift tan of 1, and we get 45 degrees for the reference angle. So 45 degrees in here and 45 degrees in here. So theta is equal to, this angle right here is 180 minus 45, so 135 degrees. And in here it would be 360 minus 45, which is 315 degrees. Okay, so if you go tan 135, we should get negative 1, and tan of 315, we get negative 1. Perfect. Okay, number 10, copy and complete the table using the coordinates of a point on the terminal arm, and they give us theta, and then sine theta, cos theta, and tan theta. And they've got us at 0 degrees, 90 degrees. These are all the quadrantal angles, right? The ones that land right on the axes. Like so. Okay, and so what we do is this. We're going to make the radius of the circle 1, And so then this would be the point 1, 0, and that line right there, that would be showing 0 degrees. And sine theta is, by definition, y over r, and if r is equal to 1, then sine theta is just the y-coordinate. Cos theta is x over r, and if r is equal to 1, then we would just get x. And tan theta is, by definition, y over x. Okay, so sine of 0 degrees is the y-coordinate, which is right here, so that's 0. Cos of 0 degrees then is the x-coordinate, which is right there, so that's 1. And then tan is, remember this is y, this is x, and this is y over x. Tan is y over x, so 0 over 1, which is equal to 0. All right, and then we sort of go in a circle up like this and put the line like that, and that makes 90 degrees, right? And the point is now 0 in the x direction, 1 for y, because the radius of the circle is 1. And so sine of 90 degrees then, sine is the y-coordinate, which is 1, cos is the x-coordinate, which is 0, and tan is y over x, 1 over 0, which is undefined. And then we go d to d to d to d down to here, and this is 180 degrees. And the coordinates of this point are -1, 0. Sine of 180 then is the y-coordinate, which is 0. Cos of 180 is the x-coordinate, which is -1. And y over x would be 0 over -1, which is 0. And then the point continues along for this whole big angle like that, which is 270 degrees. And the coordinates here are 0 for x, -1 for y. Okay, and so sine of 270 is the y-coordinate, -1. Cos of 270 is the x-coordinate. And tan is y over x, which is undefined. And we finally get back all the way around. Once you go in a complete circle, that is 360 degrees. We are back at this point with those coordinates. So sine of 360 degrees is the y-coordinate, 0. Cos of 360 is the x-coordinate, 1, and then you go y over x, 0 over 1, which is 0 for tan. All right, so there's number 10. And we will finally finish off with number 11, which says determine the values of x, y, r, sine theta, cos theta, and tan theta in each. And the first thing they give us is this. We've got this terminal arm, and the angle goes like that. And it's going through this point P, which is -8, 6. And they're showing that this is the reference angle, theta reference, as well in the diagram. Okay. X, of course, is the x-coordinate, -8. Y is the y-coordinate, 6. They want us to figure out r. We're going to have to do r squared equals x squared plus y squared. So r squared is equal to -8 squared is the same as 8 squared. So I'm going to go 8 squared plus 6 squared. And we get 100. Awesome, so r is equal to plus or minus the square root of 100. R is equal to plus or minus 10, but since it's a radius, r is 10. Awesome. So then sine of the angle is y over r, which is 6 over 10. We could put that in lowest terms if we wanted to. Cos of the angle is x over r, which is negative 8 over 10. Maybe we could do lowest terms. And tan of the angle is y over x, which is 6 over negative 8, in lowest terms, negative 3 over 4. And just looking at number 11 in the answer key, everything is looking good with this. Perfect. Okay, and we finally get to 11b, which is the same type of question. The angle is like that. It's going through the point 5, negative 12. And of course, this is the reference angle, theta reference. So x is equal to the x-coordinate, y is equal to the y-coordinate. We need to figure out r. R squared is equal to x squared plus y squared. 5 squared plus negative 12 squared. $169. So r is equal to plus or minus the square root of that. So r equals plus or minus 13 if you do the square root of 169. Bang. And since it's a radius, r is equal to 13. There we go. And then they want us to do sine theta, cos theta, and tan theta. So sine of the angle is y over r, which is negative 12 over 13. Cos of theta is x over r, which is 5 over 13. And tan theta is y over x, which is negative 12 over 5. Okay, there you go, everybody. That is an answer key for Trig Lesson 5 homework, and I will talk to you again soon, early next week, with Trig Lesson 6.